you just like plugged in the h of x to like whatever it's at.
Yeah. Yeah, just because yeah, exactly. So if this had been x squared, I'd have put x squared here. We good, Lucio? Are we already recording?
Yeah.
Okay. Can we? Okay, fine. If we're going, it's fine. Okay. Reflection. So, Kayla, you good with the time? All right. So reflections. Yesterday we talked about moving a graph side to side, and we talked about moving a graph up and down. Today I want to talk about reflecting a graph. So let's start. I think an example is the easiest way to do this. Y equals square root of x. Let's say y equals square root of x. Let's say g of x equals square root. G of x equals negative square root of x, and h of x equals square root of negative x. So we've got those three things going on here. Three functions. And the way I'm going to do this is I'm going to build out a table for the first one, graph the first one. Table for the second one, graph it, and so on. So let's build a table for the first one. Yes, this will become interesting very soon. Okay, so x and square root of x. This would be negative square root of x, and this will be square root of negative x. Okay, let's start out, just focus on the first column right now, just on square root of x. We'll go in order. Okay, we'll start here with Alex. If I put 0 in for x on this first one, what do I get out for y? 0. Okay. If I put in 1 for x on this, VNA, what do I get out for y if I just put 1 here? 1. If I put 4 here, Brian Moreno, what do I get out for y? 2. And of course I could keep doing this, right? 9, 3, etc. Let's go ahead and graph this now. So 0, 0, 1, 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3. Let me actually draw it a little bit taller. Okay, so here we have y equals square root of x. And by the way, this should be able to be done just automatic, just parent function, blah, blah. Now, let me go to Brown. Let's imagine now, so now I'm moving to column 2. So, column 3. If I plug in 0 here, remember this is g of x, so this is this one. If I plug in 0 here, Victor Mendez, what am I going to get out for y? 0. Nathan, if I plug in 1 here, what am I going to get here? Negative 1. Right. And Daniel, if I plug in 4 here, same thing as here, what do I get out for y?
Negative 2.
Negative 2.
Negative
Square root of 4 is 2. You got the negative outside. Right, I could keep going. This would be negative 3, but I think we get the picture. So let's go ahead and graph these points. So I've got 0, 0. That's already there. I have 1, negative 1. So 1, negative 1. I have 4, negative 2. 1, 2, 3, 4, negative 2. So right down here. And I've got 9, negative 3. So I've got something like this. This is g of x equals negative square root of x. All right. Now, here's where I want to get very specific with the terminology. If you look at the coordinates on the brown graph versus the black graph, somebody tell me, what is the difference in the coordinates? What is the difference in these coordinates? If you look at brown versus black. Cassandra, what do you think? The black one there, all positive, okay, and the brown one? Ah, the y's have been multiplied by negative 1. That's fine. The y's have been multiplied by negative 1. So notice The only difference between black and brown is y's are multiplied by -1. That means, this is crucial, that this right here is a vertical something. I don't want to call it a reflection. I just want to say it's vertical. I know it's vertical because it affects the y coordinate. Vertical things affect y. Okay. Right, so I could use the word reflection, which is probably right, but the risk with reflection is some textbooks, so in college you might see a textbook that calls this a horizontal reflection. The reason some textbooks say horizontal is because of the following. This is a reflection over the x-axis. You guys see that? This is a reflection over the x-axis. So I would just say it's a vertical transformation, and the safe way to say it is a reflection over the x-axis. That's the safe way to say it. If you just say that, so you know it's vertical. One second, Michelle. You know this is vertical because this is outside the action. Remember, horizontal transformations are inside the argument, inside the function. This is outside, therefore it's vertical. It affects the y coordinate, and it's a reflection clearly over the x-axis. Michelle. Can't hear you.
I was going to ask what you call it a vertical function.
A vertical function? No. I mean, a function is like an equation. I would hesitate to call it a vertical function. I would say vertical transformation that is a reflection over the x-axis. Yeah. Let me do h of x. So h of x, if I plug in 0 for h of x, we'll say, what do I get out?
For h of x?
Mm-hmm. I plug 0 in here. What do I get out?
0.
0. We do it. All right. If I plug in 1, what am I going to get out? 1? Do you have a sense? If I plug in 1 here, undefined. I cannot take the square root of -1 on the real numbers. Of course, it is imaginary, but on the real numbers, this will be undefined. Matthew, what if I plug in 4? What will that be? It will also be undefined. And even 9 is undefined. So we're running into a slight problem here. We have no coordinates to graph. How do I solve this problem? Dulce, how do I solve this problem?
Oh, wait, so we
Oh, you have a question? Go for it.
Oh, like, so we can't use what we used in algebra 2?
So okay, if I asked you this a question, right, without the graphs, I guess like in theory you could say like 2i, for example, but the risk is this graph only contains real numbers, so you can't put imaginary numbers on here, so that's why we usually just disregard it. Hector, Javier.
Wait, so we're not gonna graph?
No, we will.
Oh,
I'll show you.
What I was thinking,
Alright.
the -1. I mean, the negative, we'll take it out and be I, and according to what we learned in algebra.
But the problem is you cannot graph i's on
I
here.
know, that's what I'm going. I believe so, Mr. Kurtz, that so that the I is -1. Is it?
I is the square root of -1. Hold on. We're getting a little bit ahead of ourselves. Michelle? Yeah. Yeah, this is like a much easier solution, right? Just plug in like negative x's. Right, so if I plug in -1, then life is very easy. -1 times negative is +1. Square root of +1 is 1. If I plug in -4, -4 times -1 is 4. Square root of 4 is 2. If I plug in -9, you guys see where this is going. Square root of -9 times negative is +9. Square root of 9 is 3. So let's graph this. X -1, y is 1. -4, y is 2, and so we have something like this. Now, when you compare orange to black, it's a good show. When you compare orange to black, what is the difference in the coordinates? Orange coordinates versus black coordinates. What are the differences? What are the differences? Daniel, what do you think?
The x's are, one's positive, one's negative.
The x's are now multiplied by -1. If the x's change, this right here must be a horizontal. I'll refrain from using reflection. I'll call it transformation. And then on the next line, I'll write this is a reflection over the y-axis. I'm just mirroring the image on the other side of the y-axis. So it's a reflection over the y-axis. Javier.
So how did well is it the same thing we call it either vertical or horizontal transformation rather than reflection over the air?
No. So on exam, if we say what is happening, I would think that the best answer is horizontal transformation, reflection over the y-axis. The second best answer that would also get full credit is if you wrote reflection over the y-axis and did not write this. But if you just wrote horizontal reflection, I would not be so happy. All right, perfect. We just heard the bell. Lucio, let's stop this one.